Welcome to today's deep dive. You know when you look up in a packed sports bar or a stadium concourse?
Right, and there's like 16 screens showing the exact same live event.
Yeah, perfectly synchronized. No visual echo, no delay. Today, our mission is to decode the hidden hardware that makes that seamless experience possible. We're pulling the specs on the WolfPack 4K 8x16 HDMI Matrix Switcher.
And to be clear, this isn't just some oversized splitter you'd find at a big box store.
No, definitely not.
What's sitting in that commercial AV rack is a $5,150 18x18 modular matrix running on HDBaseT technology.
Which is wild. But getting the video to the screen is really only half the battle. To keep those 16 displays perfectly synced across a huge venue, you first have to beat the physical limits of standard video cables.
Right, because standard HDMI is, well, it uses relatively fragile low-voltage signaling.
Exactly. It degrades super quickly over distance. You basically cap out at around 12 feet before
Yeah.
the signal just drops.
Yeah.
So the obvious workaround to me might seem to be, I don't know, wireless casting.
You'd think so, but wireless simply cannot handle uncompressed 4K video in a crowded commercial space.
Because of the interference.
Exactly. Imagine 500 people in a sports bar, right?
Yeah.
They all have cell phones fighting for the Wi-Fi bandwidth.
Oh, yeah. A total nightmare.
Wireless video would just constantly buffer or drop due to that radio frequency interference, so HDBaseT bypasses the airwaves completely.
It just uses cables.
Yeah, it sends the signal over standard Ethernet cable, specifically CT6.
Which is brilliant from an installation standpoint, honestly.
Yeah.
IT departments already know how to run CT6. It's cheap, it's everywhere.
It's super easy to terminate.
Right. Plus, it's designed for long-haul data packet transmission. But how does it carry uncompressed video?
Well, HDBaseT maximizes that copper pipeline. It pushes uncompressed 4K video up to 110 feet.
Wow.
And a 1080p signal up to 220 feet.
That's massive.
And here's the kicker. It sends power over that exact same cable. Power over Ethernet.
Wait, to the receivers mounted behind the TVs?
Yep. Entirely eliminating the need for extra wall outlets up by the ceilings.
That saves so much time. But the specification that really stands out to me is the latency. We're talking under 7 microseconds over a 220-foot run.
Yeah.
That is 0.000007 seconds.
That speed is the critical mechanism here. I mean, when you're running a live feed in an auditorium, a delay of even a few milliseconds creates a weird disconnect.
Like a badly dubbed movie?
Exactly. You see the live speaker's lips moving and the screens hanging hundreds of feet away just don't match up. 7 microseconds ensures absolute real-time synchronization.
So the audio and video never drift.
Never.
Delivering high-quality video that fast is really impressive. But, if you're running a large-scale venue on Super Bowl Sunday, you don't just care about latency. You care about survival.
Oh, absolutely. The stakes are huge.
Right. So what happens if a video input blows out mid-game? You can't exactly power down a $5,000 matrix switcher to fix a dead port while a huge crowd is watching.
You can't. And that's where the industrial-grade engineering comes into play. The WolfPack uses a hot, pluggable, slide-in card architecture.
Okay, what does that mean in practice?
The internal backplane isolates the power, meaning if a single port dies, the rest of the system just keeps running.
Oh, so you literally just slide the broken card out.
Push a new one in.
Yeah.
Without ever interrupting the main system power.
It's like replacing fuses in a breaker box. You don't have to cut power to the whole building just to fix the lights in one room.
That is exactly it. And beyond that hardware resilience, the power system itself is built for worst-case scenarios.
Like power surges.
Yeah, it features dual redundant power supplies. So if one fails because of a surge, the other seamlessly takes the load.
That's bulletproof. What about actually controlling the thing?
The control architecture is incredibly deep. You can manage the routing locally via a 7-inch color touchscreen right on the front or through mobile apps.
And for the really high-end setups, you can write custom serial commands, right?
Yeah, like RS-232 scripts.
To tie the whole matrix into third-party automation systems like Control4. So a bartender can just press a single button on a keypad to dim the lights, drop the blinds, and turn on all 16 TVs simultaneously.
Exactly. So the next time you are out at a large venue watching a game, you'll know exactly what kind of complex zero-latency engineering is hiding quietly in the AV rack in the back room.
It takes an incredible amount of processing power and physical infrastructure to make things look so effortlessly synchronized.
It does, and honestly, it leaves us with a fascinating dilemma for the future.
How so?
Well, HD-based technology is currently maximizing the physical limits of standard CT6 cables to push uncompressed 4K video. It is essentially saturating the copper wire.
Ah, I see where you're going with this. So how will physical building infrastructure have to adapt when these expansive venues inevitably demand uncompressed 8K video?
Exactly.
The cables currently hiding inside the walls might need a complete rethink to handle the next generation of live entertainment. Something to think about next time you order a draft beer.